Hello everyone, welcome to the first lecture on econometrics. In this video, I'm going to discuss in detail as to what is econometrics, what this course has for you, what all we are offering in this course. We're also going to discuss in detail as to what are the prerequisites for this course, if any, and who all can go ahead and take this course. But before that, let us try and understand what is econometrics. The word econometrics ideally means economic measurement. So we try and we give measurement or we give value, we give numbers to economics, and that is what econometrics is all about. There are several definitions that we have related to econometrics. One of the way how econometrics can be defined is the social science in which the tools of economic theory, mathematics, and statistical inference are applied to the analysis of economic phenomena. What does this mean? This means that in econometrics, we are trying and measuring the economic theory. For example, I understand that as income increases, consumption should also increase. The more the income, the more is the consumption. This is the basic Keynes law of consumption. However, we want to understand that when consumption increases, when income increases, by what amount does consumption increase? The moment I measure that, the moment I give you a number for that, that becomes econometrics. So here I'm trying to get a number for the economic theory that is already lying behind this number. Economics is full of theories. There are a lot of macroeconomic theories, microeconomic theories, a lot of public economics theories, etc. We might want to actually get into quantifying these theories through econometrics. Econometrics can also be defined as a social science in which tools of economic theory, maths, statistics inference are applied to the analysis of economic formula through tools like R, Python, Stata, etc. So we have these tools in place which will help us to quantify these economic theories. To understand how these tools can be used, we have a separate course of econometrics using R. Which is a counterpart of this course, and it helps you to understand how can you go ahead and use them in via R, via coding, via Excel, etc. Now let us go ahead and understand why a separate discipline is actually required. See, as I just mentioned, economic theory makes statements or it makes hypotheses. It tells you that, you know what, I think that there is a relationship between income and consumption. There is a relationship between income and savings. The more the income, the more would be the savings. There is certain relationship between inflation rate and unemployment rate given by the Phillips curve. So it gives you theories, it makes statements, it does some hypothesis. It tells you that, I think this is the hypothesis testing that is there behind. It tells you, for example, that, when you reduce the price of a commodity, the quantity demanded would increase. So, it goes ahead and postulates a negative or inverse relationship between price and quantity demanded, or a negative relationship between inflation rate and unemployment. However, it does not give you a numerical measure of the relationship between the two. It does not tell you as to when you will decrease the price, by what amount will this quantity demanded increase. That is the job of econometrician. Econometrics will help you to give those numerical estimates. So econometrics gives empirical content to most economic theories. It is mainly interested in empirical verification of economic theory. This is a theory that I have in mind. Now, I really give you a data of prices. And I give you data of quantity demanded. Can you run a model and justify this negative relationship? That is the role of econometrics. Methodology of econometrics. Broadly speaking, there are 8 main steps that we follow as part of econometrics. First is to have a theory in mind. For example, a negative relationship between price and quantity demanded. The second is specification of mathematical model of the theory. You give the model behind this theory. Third, specification of statistical model or econometric model, in which you go ahead and you give the actual prices and you give the quantity demanded, or you create these null hypotheses. Null is there is no relationship. To understand what is null and what is alternative, please take a course on statistics, because that is where I'm going to go ahead and do what is hypothesis testing, how do we do it in a 1 sample case, how do we do it in a 2 sample case, etc. So my null hypothesis is that there is no relationship between price and quantity demanded, and my alternative becomes that there is in fact a relationship. The relationship negative or positive if I want to do a one tail test, or just talking about the relationship that there exists some relationship if I want to do a two tail test. The next step is to obtain the data. So, I have to go ahead and verify this hypothesis testing that I just created. I have to obtain data for that. I have to define my parameters that, my quantity demanded is beta naught plus beta 1 price. There is a relationship between quantity demanded and price, which is a linear relationship, or there is a relationship between quantity demanded and price, but the relationship is actually quadratic, or whatever model I think would suit my data best. Now, there is also a way to understand which model is going to suit my data best. Again, something which we will learn as we go through the course of econometrics. The next is to do this hypothesis testing that I have already created. I want to go ahead and understand whether beta 1 is significant or not. If beta 1 is not equal to 0, is proved, then beta 1 has a positive or a negative value, and there is a relationship between quantity demanded and price. More sure, we understand that beta 1 should be negative to have a negative relationship between quantity demanded and price. However, if I'm not getting enough evidence to reject my null in favor of alternative, I would be stuck with the concept of beta 1 equal to 0, and hence there would be no relationship between price and quantity demanded. So this is what I'm going to test here. I can do a Z test, a T test, F tests, chi-square tests, depending on what model I'm talking about and what I am testing. Something that I will explain you as I go ahead in the course. The next part is forecasting or prediction. So, once I have proved that there is a negative relationship between quantity demanded and price, I want to go ahead and ask a question like this. When the price is 100, what do you think is the quantity demanded? I want to forecast or predict or understand the value of quantity demanded for a given level of price. The last concept is using the model for control or policy purpose. Once I have proved that there is a negative relationship between quantity demanded and price quantitatively, that when you increase the price by 1 unit, quantity demanded decreases by 0.8 units. Once I've given you this measure in numbers, how can you use this in policy? So once I've proved that there is a negative relationship between inflation rate and unemployment, and I've given you a number, you as a policymaker understand that the moment you increase inflation by so and so percent, you will definitely face a decrease in unemployment by so and so percent. So, that relationship can be used for policy purpose. Now, let us go ahead and understand the first thing, which is statement of theory or hypothesis. Now, what is the statement? The statement is what you want to test. So, for example, Keynes, and this is, exactly in terms of Keynes had stated that the fundamental psychological law is that men, women are disposed as a rule and on average to increase their consumption as their income increases, but not as much as their increase in income. Now, let us try and understand what he wanted to say. He wanted to say that, if your income increases by 1,000 rupees, you will definitely increase your consumption, but you will not increase your consumption by 1,000. Maybe you will increase your consumption by 800. Maybe you will increase your consumption by 700. Maybe you'll increase your consumption by 900. But one thing that is sure is that you would not want to increase your consumption by all the $1,000, because as a human tendency, you would also want to save some part of it. And he went ahead and he said that, what? This is nothing but marginal propensity to consume. Marginal propensity to consume is how does my consumption increase? By what amount does my consumption increases when I increase my income? So that became the marginal propensity to consume. In short, Keynes postulated that the marginal propensity to consume, the rate of change of consumption, is greater than 0 but less than 1. How? Because of this. He mentioned that, whenever consumption will increase, it will be less than the increase in income. If income increases by 1,000, consumption will increase, but not by 1,000. Consumption will increase by a lower amount. So if I bring this change in y down, or I divide both the sides by change in y, just understand this. Change in C is less than change in y. Divide both the sides by change in y. Change in C by change in y is less than 1. Marginal propensity to consume is less than 1. This shows that the marginal propensity to increase is less than 1. Similarly, I know that change in consumption due to change in income will definitely be greater than 0, because I am changing my consumption by some positive amount. When income increases by 1,000, it's not that I do not change my consumption at all and I keep it at 0. I change my consumption also. So, because change in consumption is greater than 0, change in consumption by change in income will also be greater than 0. Marginal propensity to consume will be greater than 0. So this over and all, actually this statement here that says that marginal propensity to consume is between 0 and 1. Actually, I want to take it strictly without the equal to sign, is nothing but, in general terms, The statement is that whenever your income increases, you will increase your consumption, but you will increase your consumption by an amount which is lower than the increase in income. So anyhow, this is the first step in which you give statement of the theory. Now, this is a statement that we just picked from history. To be more specific, it's a theory that has already been assigned in economics. I want to go ahead and specify a mathematical model. Although Keynes said that there is a positive relationship between consumption and income, he did not went ahead and gave a precise form to it. He said that, all that he's saying is that there is a positive relationship between consumption and income. But what kind of model exactly exists is not very clear. So we go ahead and we write a linear model for this. It could have been quadratic. It could have been x square. It could have been anything. As we go ahead, you'll understand there are various models. There is a reciprocal model, there is another model, and so on and so forth. There are tons of model that you will study, but you have to understand that this is something that you will attain from the kind of analysis that you do. Nobody went ahead and gave you that as part of the theory. They said that there is a positive relationship. Is that relationship linear, non-linear, quadratic, log-log, lin-log? What kind of relationship exists is not clear. So I go ahead and I start giving it a formal mathematical relationship in form of a model. Now here, you can go back and refer to maths, but I understand that whenever I write any equation of a line, which is of the form y is equal to mx plus c, something that I've covered as part of my maths videos, whenever we write any equation like this, m is the slope and c is the constant. So whenever we write a relationship y is equal to mx plus c, we actually, whatever comes with x becomes my slope and this becomes my constant. So this is exactly what this relationship is all about. This is the slope and this is the constant. We'll do this in pretty detail as I go ahead across the course of econometrics. Now, the variable that appears on the right hand side, this variable is independent. The variable that comes on the left hand side is dependent. And it is pretty clear, dependent on x. Y is dependent on x. As x changes, y will change because y takes the form of beta 1 plus beta 2 x. When you put x as 1, y is beta 1 plus beta 2. When you put x as 2, the value of y will automatically change. So the moment you change the value of x, you are automatically changing the value of y. And that is exactly why y has to be dependent on x. So, you go ahead and you give specification of the mathematical model. This is how the model appears in econometrics. You have x. X is your independent variable. Always remember that the independent variable comes on the x-axis, always. Consumption is dependent on income. If income is something, correspondingly you get a value of consumption. If income is something else, you get another value of consumption. So consumption depends on what value of income you are talking about, and therefore consumption is dependent and hence comes on the y-axis. A dependent variable will always come on the y-axis. Now, as I just told you, y is equal to mx plus c and y is equal to beta 1 plus beta 2x, I know that this was the constant. Constant because, this is c. This is constant, this is slope. So constant has to always come as an intercept. So beta 1 becomes the intercept. I will discuss this in very much detail as part of chapter 2. So this becomes my intercept. Beta 2 is slope. And this is my slope. At any point of time, this can be slope. Slope of a line. Slope of a line. What is the relationship between y and x is shown by the slope. So this slope of the line is beta 2 at any point of time. Beta 2 tells you that, for every change in x, what is the change in y? You change x by this amount, you change y by this amount. So actually slope is nothing but perpendicular by base. I'll do this in detail again as part of chapter 2. This is just an introductory video for you to understand what econometrics is all about. The next thing is specification of the econometrics model. Now, you know what? The mathematical model is this, that once, your income, consumption is dependent on income, and that's your mathematical model. You've given that a model form. Now, what you're going to do is you're going to give an econometric model of consumption. The moment we talk about econometric model, we go ahead and define an error term with it. Why is that the case? Because whenever we talk, and something that will be very, very important and will become clear as we go through chapter 2 to 5 of the book of Gujarati and other econometrics books, is that this was an exact relationship. But then the relationship between income and consumption might not be exact. I might predict that, supposedly you predict a relationship like this, that y is equal to 80 plus 0.8x, where, x is income and, y is consumption. And I tell you that what happens when your income is 100. You tell me that when income is 100, consumption would be 80 plus 0.8 into 100. And so consumption would be 80 plus 80, 160. So when income is 100, consumption will be 160. Supposedly you go ahead and define a model which looks something like this. Then the next question that I ask you would be, what? Tell me what happened in reality. Tell me what happened when you gave a person $100. And you tell me that, when I gave a person $100, when his income became 100, this is income, his consumption was actually, something around 85. Now, the actual consumption was 85. What your model predicted was this. There is a difference between what you predicted and what the actual consumption came out to be. And there will always be a difference between the two things. So you will predict something out of your model, out of the relationship that you have got. And, when you in reality would see something, the value will not come out to be exact. It will not come out to be exactly precise. And hence the term error comes into place. Error is the difference between what you predict and what your actual value comes out to be. So the actual value is what you predict plus some ups and downs. Sometimes, you tell me that consumption actually is 185. The person, not only consumed his $100, but he also went ahead and did some dis savings. He sold his gold and he started consuming that money also. In that case, he consumed 185, you predicted 160, you still made an error. You could not predict exactly the right amount. And that is again the case of having certain error terms. So, the earlier equation that we built is of less interest to an econometrician, as it's an exact or a deterministic relationship. Relationship between economic variables are inexact. To have that inexact relationship, we allow the error term, something that will stay with you throughout the course of econometrics. We will discuss in detail about the different assumptions we make about the error terms, what happens when these assumptions are violated, what is predicted variable, what is non-predict, what is your explained variable, what is independent variable. Everything would be discussed in detail. So the error term represents all those factors that affect consumption but are not taken into account explicitly. This is important. I, for now, had built a model where I said that my income is going to determine my consumption. But I have to also understand that there are other factors that are going to determine my consumption. For example, my consumption would be affected by my family's wealth. If I earn lower income, but I come from a very rich family background, in that case, my consumption would be very high. Now, that is the example where my error term would represent that, what? There is a difference between what you predicted, because you only thought that your consumption will depend on your income. But, person's consumption ended up depending on the wealth of the family also, and he consumed more. The difference between what he actually consumed and what you predicted is error. That error tells you that you did not take into account that wealth of family, which actually affected the consumption of the individual. So that is what an econometric model is. It goes ahead and takes into consideration the inexact relationship between economic variables. Now, the next thing is obviously to obtain data. So to estimate these beta 1s and beta 2s and to get the relationship between y's and x's, we need data. You have to tell me that, when price was this, what was quantity demanded? When price was this, so that I can make a model on this. How to make a model, how to do modeling is covered as part of this course. Once that is done, you will predict the values. You will come up with a relationship. This relationship tells you that, what is xt? Xt is your income. What is yt hat? That's the level of consumption that you predicted. So, this tells me that, when my income is 100, my consumption will be minus 299 plus 720. The other thing tells me that, what, when my income is 400, my consumption will come out to be minus 299 plus 70.72 into 400. And so on. So, this is a model that I defined. I keep putting the values of X, which means I keep putting the value of income, and correspondingly, I keep getting the value of consumptions. This is something that I will help you understand how to, actually go ahead and define these variables, how to go ahead and calculate beta 1s and beta 2s, what are beta 1s and beta 2s for that matter in detail. Everything would be covered. So this is just, an introduction. Not to worry if things are not very clear as we go ahead during the introduction, because for each slide that is presented here, We have full-fledged chapters that explain how these things came out. Finally, we do a hypothesis testing. Now, this is something where, I would prefer you to have statistical knowledge in background to understand what is null, to understand what is alternative, to understand what is type 1 error, to understand what is type 2 error. So a short course on statistics would be good. However, as I go along, I will also try and explain these in some aspects. I'll explain what is null, what is alternative. But if you go ahead and take a course on statistics, or do a course on statistics, or read some books on statistics, things will make more sense as we go and do hypothesis testing. Finally, because I have this relationship, I can put different values of X and get different values of Y. X was my income level and Y was my consumption level. So this tells me that, when I put the income or GDP is nothing but the sum of incomes. GDP is the total income of the economy. So if I go ahead and add the total income of the economy, the total consumption of the economy will be this much. So an economy that earns 11,319 billion would have a consumption of 7,870 billion. Right? Now, this is what you predicted. Here comes the interesting fact. When we actually went ahead and asked people how much they consumed, and went to the level of the economy as a whole, the consumption that was reported was 8044 billion. The total consumption that actually took place was 8044. But the model that I predicted gave me the value of 7870. So which means my model could predict that it is close to 8,000, but there was this 2,000 gap that still existed. My model went closer to 8044, but my model predicted that consumption will be 7870. And actually, when I went ahead and I collected data, consumption came out to be 8044. This equation tells you that approximately these $174 billion were unpredicted. You could not predict these $174 billion, which should have been predicted. So this becomes your error term. The error term is the amount that you're not able to predict. So, something might be an actual value. Actual came out after 2006. It came out in 2007 that people had consumed 8044. But, at the end of 2005, I predicted that, 2006 people will consume 7,800. Something like that. So I predicted people will consume 7,800. People actually consumed 8,000. The gap becomes the error. Okay. So, this is what we will discuss in detail as to what is the error term, how to minimize this error term, how to get as close to the actual value as possible. Use of model for control or policy purpose. Once I have built this model, what is the question that the government has in hand? Now, the government wants to hold a consumption at some level. The government says that, what, I at any cost want my consumption to be 8750. What level of GDP will ensure me that I get that consumption? So I'm using the model that I built here to go the other way around and use it for policy. This model said that, what, if this is the income, this will be consumption. If you change the income, the consumption will keep changing. But now I'm going ahead and asking that, as the government, I want to have this much level of consumption from people. I want to ensure that people consume this much. What level of GDP will ensure me that? So now I'm holding this constant. I want to hold this dependent variable at certain value. I want to say that dependent is fixed at 8750. What value of independent variable will ensure that I have 8750 as the dependent variable? That is how we use it for the purpose of policies. Now, choosing among competing models. Sometimes we have two models that fit the data. Which model is fitting the data better is something that we will do as part of this course. We will try and understand whether a linear model is fitting the data better or a log-log model is fitting the data better. What fits the data better? Now, let us try and understand the different types of econometrics. The first is theoretical econometrics. Theoretical econometrics is concerned with development of appropriate methods for measuring economic relationship specified by econometric model. This is something that I will cover as part of this course. Applied econometrics is when we use tools of theoretical econometrics to some study aspects. Like when you apply econometrics, so you are, at the end of the course, you understand how to calculate betas, how to, go about and create a model, how to check for different assumptions, and, what happens when these assumptions are violated, what to do about that. So once you have all that theory in mind, you go ahead and you apply that to investment function, to production function, etc. This is an advanced econometrics course, something that is covered as part of another module of econometrics. But for that, this becomes a prerequisite. Only after, and here I have two modules, module 1 or course 1 and course 2. I'll clearly lay out what is covered in what, post which I lay out what would be covered in applied econometrics. Basic concepts of statistical estimation and hypothesis testing remains a prerequisite. My suggestion, as I have been repeating again and again, would be to go ahead and take a course on statistics first, which will have hypothesis testing. It covers what is the normal distribution, it covers what is binomial distribution, something which would be required here yet again. So do that course of statistics and then go ahead with econometrics. However, that said, I will also in bits and pieces cover that hypothesis study in this course also. Now, let us go ahead and try and understand the syllabus of this course. This is Econometrics Level 1. In Econometrics Level 1, I will cover all about what is econometrics, the various regression models in econometrics, and the different assumptions that we make in the CLRM model, what happens when the assumptions are violated, how to go about those assumptions. The entire course of econometrics is covered for now in three main parts. Econometrics Level 1, Econometrics Level 2, Advanced Econometrics. Actually, this is going to be applied econometrics. Apart from this, I'm also going to go ahead and cover econometrics using R. For now, I'm going to discuss the core structure of econometrics level 1. The first chapter is going to be the nature of regression analysis. Now, the book that I'm going to follow throughout for your practice is going to be the book of Gujarati. This is like the best book that I would go ahead and recommend. You can in bits and pieces refer to DeVore, but we would be covering that as part of statistics anyways. So this is a book of Gujarati which can be referred, which is Basic Econometrics. And what I'll do is I'll go ahead and I'll also give you the link of this book by Gujarati and Porter. So this is the book which you can go ahead and refer to. Now, coming back to the course, I'm going to go ahead and cover chapter 1, which is the nature of regression analysis. I'm going to cover chapter 2, which is going to be two variable regression analysis. We're going to go ahead and talk about what is the problem of estimation. How do you go ahead and estimate these betas? What are the problems that you face? We're going to go ahead and talk about classical normal linear regression model. What are the assumptions that we have to make in CNLRM model? What happens when these assumptions get violated? We're going to go ahead and talk about the two variable regression, in which I'm going to talk about interval estimation and hypothesis testing. Here, I'm going to teach you how to form hypotheses, how to go ahead and calculate intervals, what is interval estimation, what is the difference between confidence intervals and predicted intervals. We are going to go ahead and talk about certain extensions of the two variable regression model. This is where we talk about finally forecasting the two variable linear regression model. Once we complete this, we go ahead and we talk about the multiple regression analysis. So, what you can do is you can consider this as part 1A of the syllabus. Part 1A of the syllabus is all about two variable linear regression model. Part 1B of the course is all about multiple regression analysis. Here I'm going to talk about what is multiple regression analysis, what are the problems that we face while we have to estimate a model which has more than one independent variable. What is the problem of inference? What do these betas represent in case we jump on to a multiple regression analysis model? And finally, I'm going to go ahead and talk about the dummy variable regression model, where I'm going to talk about what happens if one of the independent variable is in fact a qualitative variable. Something that I forgot to mention previously, in the extensions of the two variable regression model, I'm going to talk about all these models like log-log model, lin-log model, exponential model. I'm going to talk about the quadratic model, etc. So these models are also going to be reciprocal model. These extensions of the two variable regression model will be covered as part of chapter 6. The next part, now this 3 chapters can act as part 1B. This covers everything related to single equation regression models. Single equations. there can be multiple equations also, something which is not covered as part of the first part of econometrics. So this is all about single equation regression model. Now, the next part that we are going to cover as part of this course, which is part 2, is what happens when we relax the assumptions of the classical model. This is related to multicollinearity. What happens if the independent variables are correlated with each other? Heteroscedasticity. What happens if the error variance is not constant? Autocorrelation. What happens if the error terms are correlated? And econometric specification, which is when you have to specify which model is the best model and you have to do a diagnosis testing. This is part 2 of this course. This is all what is going to be covered as part of the first level of econometrics. The entire course would be in total having 13 chapters, plus we would be doing numericals. A lot of numericals would be posted along with their answers. And definitely we would be covering MCQs related to econometrics, both basic level and advanced level. So this is all about this subject. Thank you.